Snap is a programming language developed at the University of California at Berkeley. You can access this program by going to snap.berkeley.edu. And once you're there, you simply run Snap. And that puts you in the middle of the programming language. One of the first things you'll want to do is create your own login. And you can do that with this symbol that has the shape of the cloud in the top left-hand center of the screen. That will allow you to save your work as you work through different activities and projects. In this module, we're going to introduce Snap, and we're also going to introduce the concepts of frequency and period in the context of a revolving object. Now, I can make this object in the middle of the screen on the right rotate by using the turn command, and if I just click turn, it will rotate. This object is called a turtle, and I can make it rotate around the tip, which is the default, or if I go up here, I can make it rotate around the middle, which is aesthetically more of what I'd like for this particular application. If I want, I can cause the turtle to point straight up just by using the point in direction command. And so now I can start it out there. And I'm going to cause it to rotate around in 90-degree increments. So now each time I click turn, it will rotate 4 times. If I'd like this to go on for a very long time, I can add a loop. In this case, I'll just ask it to keep turning forever until I tell it to stop. So if I start it turning, it will turn until I click the red stop button in the upper right hand corner. I'd like to slow this down so I can get a better idea of what's occurring and add a wait, and so now every time a second elapses, it makes a quarter of a turn. I'm going to make a little timer that will allow us to track seconds. To do that, I'm going to use a variable. Name the variable seconds. A variable is literally something that varies or changes. In this case, the thing that'll be changing will be seconds. So I'm going to start out with a count of 0 seconds, and I'll also start it pointing straight up. And then each time it turns a quarter of a turn, I'll update the seconds by 1. And so now I can track the seconds, and it will start rotating around. Now, in this case, I'd like it to start out. I originally set the timer to start at 0, but if I really want it to accurately track the seconds so that once it's made 4 quarter turns, it'll record a full second, I'll need to set seconds to 1 at the beginning. And now, when it's straight up, I've gone 4 seconds. Now, I got a timer that I can use to track things, but I'd like to establish the concept of revolutions per minute. And in order to do that, I'm going to need a way to tell when the seconds, when it's made a complete turn. And the way I can do that is to create another variable to track revolutions. So now I'm got the second variable, which I'm also going to initialize when I start out. And then I'll be able to tell that I made a complete revolution when the turtle is pointing straight up. And so that'll allow me to say if the direction of the turtle is equal to 0, then I know I've made a complete turn. And at that point, what I'd like to do is change revolutions by 1. And so now I've got a way of tracking not only the seconds, but how many complete turns have occurred. To make this a little more convenient, I'm going to add a code block that allows me to start everything by clicking the green flag. And so now it's going to track the seconds, but it's also going to track the revolutions. And I can let it continue turning until I reach whatever point I'd like to stop it. And I'm going to let it run until it reaches a complete minute. So now I've reached the point at which the turtle has completed 15 revolutions in 1 minute. That tells me that the rate of turning is 15 revolutions per minute, or 15 RPM. It also tells me that the time it takes to take one complete revolution is 4 seconds. So since the period of time is 4 seconds, I could say the frequency is 15 revolutions per minute, or 15 RPM, and the period is 4 seconds. In the next module, we're going to explore how these concepts of rate, frequency, and period apply to sound and vibration. And the concepts are much the same, except typically we talk about, instead of turns per minute, we talk about cycles per second when we're talking about vibration and sound. But the concept is the same, and many of the commands that we use to track and operate, work with these concepts, are the same as the ones we've introduced in this beginning module.